So what we've looked at so far has been pretty much one-shot deals. You make one payment, so you have some sort of a present value, and then it sits there, and there's no payments or withdrawals made until the end when you get to some sort of a future value. And in the middle, you can either have simple interest, where absolutely nothing happens until there's some action, like that withdrawal or whatever at the end of the account, or there's compounding. And in the compounding, of course, interest is added in every little while, regular periods during the term of that account. But there are no additional funds put into it. If there's a payment made, if it's a loan and there's a payment made, everything has to be calculated out and started over after the payment. So it's not like it's organized regular payments. What we're going to look at tonight is what happens when we have those organized regular payments or regular withdrawals from an account. And it's what we call an annuity. An annuity is actually a more specific term that used to be very popular, or used to describe a specific type of account. Generally, it was an insurance company you would purchase an annuity from or get into an annuity as a type of investment. Really, all an annuity is where you have regular periods, a payment in regular periods over a term. So over time. And that payment can either be building up a balance or it can be paying down a balance, like in a loan. The formulas we're going to use over the next few weeks can also be used. At some point, we'll show you how to use them to calculate what the payments would be on a loan or on a mortgage and stuff like that. Okay, so let's get started about some of the vocabulary here. Most annuities have a couple of different phases. For example, let's say you're saving on an annuity for retirement. So here's the date that you're going to retire. Well, before you retire, you're going to be paying money in. And the balance on that annuity is going to be growing, hopefully, as you pay in. This is what we call the accumulation phase. Money is accumulating into that account and its balance is getting larger and larger. If that is a retirement account, then after you retire, you're going to start drawing on it at some point, and most likely the balance is going to slowly start to sink as you draw the money out and use it for your expenses. This is what we call the liquidation phase. So what we're going to be looking at tonight mostly is the accumulation phase as we're paying in. There are two types of annuities we're going to look at. Paying into an annuity or paying into an ordinary annuity. We've run into that word ordinary before. When we were talking about interest. Ordinary interest meant it was simplified down to 360. Paying into an ordinary annuity is also kind of the simpler way to do it. It has nothing to do with the number of days in a year. But what it does is it's stating the payments are made at the end of every period. So if you're going to be paying in every month, a certain amount every month, that payment is made at the end of the month. So you don't have any interest on it during that month. The interest doesn't start until the next month. So ordinary annuity. Payments are at the end of the month. The other option is something called an annuity due. In an annuity due, payments, I shouldn't even say month, I should say period. payments are at the beginning or the start of the period. So what does this mean? If you're looking at making quarterly payments, let's say, for an ordinary annuity, your payment's going to get made at the end of each quarter. So at the end of this first year, this one here hasn't had any interest on it because it just got made. This one has 3 quarters worth of interest. This one has 2 quarters worth of interest. This one has 1 quarter worth of interest. In an annuity due, your payments are made in at the beginning of the period. So your payments would be made in these 4 spots. So this first payment has 4 quarters, 4 periods worth of interest. So the annuity due, really, it's just a month ahead or 1 period ahead of the ordinary annuity. And at some point, we'll have to make an adjustment to figure in a little bit of extra interest for the fact that that's sitting there a little bit longer. So let's actually get to some math and some formulas. Enough vocabulary crap. So let's look at paying in to an ordinary annuity. So you pay into an ordinary annuity. The amount that you will have, the future value, will be equal to the amount of your payment. Now, I am not going to write this formula the way it's written in the book. I'm going to write this formula the way it would get punched into your calculator. And yes, you need to do everything, include everything that I put in here has to be included in your entry. So it's your payment times, there will be 1, 2, 3 open parentheses. 1 plus your rate divided by n. Remember, n is the number of periods in a year. Your rate was your percentage written as a decimal. Close parentheses. To the power of NT, the total number of periods, the number of years times the number of periods in a year, minus 1. Close parentheses. Divided by, open parentheses, R divided by N. Close and close. I don't know why my lettering and my parentheses all got bigger and bigger as I went, but apparently that's the mood I'm in tonight. Okay, well, you're just copying me. Huh? So anyway, for example, let's say that you are 30 years old. You're hoping to retire at 65. You figure that you can afford $200 a month that you're going to put away. Which I know, yeah, that might be a little stretch. That might be a little much, but we got to start somewhere. So the amount that we're going to have in the future is that $200. And let's say that you figure you can earn 6% interest. The fact that we're paying in $200 per month means that we're going to have to, our period is going to be per month. You're going to have to compound interest every month. So it's going to be 200 times 1, 2, 3 open parentheses. 1 plus, what's R? Yes, you have to have the 3 open parentheses on your calculator. Yeah. Well, in the paper, it doesn't matter, but when you enter them in the calculator, they have to be there, so I put them on the paper just so you don't forget them. So 1 plus, what is R? 0.06. Divided by, it's monthly, right? So 12. To the power of, well, how many years?
35.
Yeah, from 30 to 65 is 35 years times 12 months in a year, since it is monthly, is 420 periods. So this is to the power of 420 here. Minus 1. Close my parentheses. Divided by, open parentheses. 0.06 divided by 12. Close and close. Let's see what happens here. So 200 times 123. 1 plus 0.06 divided by 12. Close. Power 420. Now some of your calculators, mine included, might require you at this point to get out of the exponent. You have to use the arrow key. So you're out of the exponent now. Minus 1. Close parentheses. Divided by, open parentheses. 0.06 divided by 12. Close and close. And we hit equals. And this person ends up at 284,942.06. Then you did something wrong. Start going back to paper and pencil. So 200 times 1, 2, 3 open parentheses. Okay. So just that $200 a month at only 6% interest is going to give you $284,000, almost $285,000 in retirement. That's not bad. Let's say you go a different route. Let's say you just can't afford it. Can't afford to take money out of your monthly check. You decide, you know what I'm going to do is I'm going to take my tax refund every year. I'm going to put that tax refund away, and I'm going to use that to build up my retirement, my annuity. So let's say you're going to do the maximum $5,000 a year that you're allowed to put in that IRA. And let's say that you're 35 years old. What's that? Yeah, it's probably too late to save for retirement if you're 350. Hope to retire at 60. And you figure you can earn about 8%. So this is going to be 5,000 times 1, 2, 3. What's next? 1 plus 0.08 divided by 1. It's annual. The power of 25. Where'd that come from? Yeah, 60 minus 35 is 25 years. Times 1 period of years, 25 periods. It's the power of 25. Then what? Minus 1. Close. Divide by. Open. 0.08 divided by 1. Close and close. Probably don't really even need to divide by 1 there. So we have 5,000 times 1, 2, 3. 1 plus 0.08 divided by 1 to the power of 25. Arrow out. Minus 1. Close. Divided by. Open. 0.08. I ignored the divided by 1, but we all know it's there. So 365,529.70. There you go. What do you think?
What's the average interest rate?
Depends on how long you leave it there. And depends on how risky, if you're willing to make it risky, you can get, over the long haul, you can get, 10, 11, 12%.
At the end, not starting out.
Yeah. I mean,
What's the average for starting out?
well, if you're only going to have, the problem with interest, let me pause it. Okay, well, there is in your book on page 495 through 496 a future value table. This future value table, very much like the compound interest, the compound future value of $1 from the compound interest unit last week, tells you what the balance will be at the end. So if I can get to the right page, here we are, 495, 496. Now the thing here, just like with compound interest, this goes off of a rate per period and the number of periods. So just to make this work, I'm going to do a little bit of a contrived example. Let's say you're going to invest $500 per quarter. And you can get 8%. And let's say you can do it for, I guess it goes up to 40. So you're going to do it for 10 years. What would be your balance at the end of the 10 years? Your future value. Well, our formula here would do this, but we have, first of all, number of periods. Yeah, 10 years times quarter, so 4 per year is 40 periods. What is your rate per period? 8 is your rate. Your rate per period, however, is the 8%. That's an annual rate divided by 4 periods per year is 2% per period. So what we're looking up in our chart is going to be 2% and 40 periods, which will give us 60.402. Good. That's our annuitized formula, future value factor. So what that means is we take our payment, $500 per quarter, 500 times 60.402 gives us $30,201. Well, the fact that it actually came out to an even dollar probably warns you that this is a rounded off factor. A little bit rounded. Let's take a look at what the formula would give us as an exact value. So $500 is our payment times 1, 2, 3. 1 plus 8% is 0.08 divided by 4. Close parentheses to the power of 40. 10 years, 4 quarters in a year, 40 quarters. Minus 1, close, divided by, open. 0.08 divided by 4, close and close. So 500. Here, give me just a second, I'll double check here. Close divided by open. 0.08 divided by 4, close, close. Gives me 30,299 cents. So this one, it appears the table factor is pretty close. You're about a penny off. Actually, 9/10 of a penny off to be exact. What's that?
Or wait, no.
Actually, the bank gave you an extra penny. The bank wants back their penny. I'll teach you to complain. So anyway, that's the table. You guys see it, love it, know how to use it. Yes, my math lab uses the table. Yes, I think it sucks.
I like it.
You did?
You liked the homework last time?
No, I like the 18 problems, but
Yeah.
It was only 18 problems.
yeah, that took an hour and a half.
Yeah, it was a nice 5 to 8 problems.
Yeah.
Those are quizzes. The quizzes only have 5 to 8 problems.
Well, the homework's going to have a lot less.
Well, let's say that Casey says, you know what? I want to retire in 30 years. I figure I will need $1 million to retire. Casey's a little bit needy. High maintenance. It's all those razors and hair dye that. So anyway, he's going to need $1 million in 30 years to retire. If he thinks he can earn an average of 9% How much does he have to put away each month to get this? Well, this is just like with the future and present value calculations for compound interest we did last week. Same thing happens here with the annuity formula. It's just exactly the same formula, only one little thing changes. So here the payment is equal to that future value, instead of multiplied by it, divided by 1, 2, 3, blah, 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 blah. Everything else stays the same. Let's put the numbers in. So the payment that we're going to have to make every month is going to be $1 million. Divided by 1, 2, 3. 1 plus 0.09. Divided by 12 because it is monthly. 30 years, monthly is 360 minus 1. Close divided by open. 0.09 divided by 12. Close and close. 1, 2, 3, 1, 2, 3. Divided by 1. So 1 plus 0.09 divided by 12. Close. Power 360. Minus 1. Close. Divided by open. 0.09 divided by 12. Close. Close. And we get $546.23. So only less than $550 a month. In 30 years, Casey could possibly retire on $1 million. You should start putting that away for me.
Do they protect that then?
That depends on how you invest it.
Well, if everything crashes,
Well, it depends on how you have invested. You might have it invested in bonds that aren't affected by the crash or in money markets, but then you might only be getting 5 or 6% instead of 9, 10, 11%.
In the bank, like if the bank gets robbed.
If the bank gets robbed, that's FDIC.
Yeah,
That's all insured.
you're insured up to 125,000.
I think it's up to 200,000 or 250,000 per
We're not
year.
paying 200,000.
What's that?
Investing 200,000.
Pretty much. That's actually a good point. We made 360 payments there. How much did we actually pay into this? Well, we made 360 payments of that amount. So it's, just under $200,000 you paid in, but you're getting back $1 million at the end. Not bad at all.
A lot of months though.
Well, it's a lot of months. That's $550 a month is a lot every month.
Well, it depends.
But you think about it. I mean, I know a lot of people that buy $50,000 trucks that have a $550 payment.
I agree. I can look at that way now if I want to. I really doing it.
Well, you got to get over that idea that you have to eat every day.
Even with the 2 kids, I think I could look at that way.
See, if they just took turns, they both get lunch every day, but one of them skips supper on odd days.
They just don't get clothes.
Yeah, no clothes. The oldest one gets clothes. For Christmas, you all get clothes. No toys. Yeah. She'll probably.
I have 2 pairs of boots and I got it all set up.
So anyway, let's go back to Casey. So let's say Casey now decides, geez, that $550 a month is just too much. So he's still looking at 30 years. He still wants to be a millionaire. Still thinks he can get 9%. But what he figures he can do is he can take his tax refund. Him and his wife can both take their tax refunds every year and put them away and see if they can be a millionaire. So 1 million divided by 1, 2, 3. How does this change things? Well, it's 1 plus 0.09 divided by 1 to the power of 30 minus 1. Close, divide by open, 0.09 divided by 1, close and close. Do you think this is going to change things a whole lot? If he was paying about $550 a month, which is about $6,600 a year before. Just the fact that it's now down, it's still 30 years. It's just it's paid once at the end of the year rather than every month. Divided by 1, 2, 3, 1 plus 0.09 9 divided by 1, I'm going to leave off. Power of 30. Out minus 1. Close divided by open 0.09. Close, close. $7,336.35. Definitely better off making the monthly payments than doing one payment a year.
That's like $612.
Yeah. What do y'all think? Good stuff?
Okay.
Okay. Let's have you try one. Now you got to remember, are we paying in? Or am I giving you the monthly payments and we're looking for the future value, so we're multiplying? Or am I giving you the future value and we're trying to find the monthly payment, so we're dividing? Make sure you keep that in the back of your head. So in this example, if you pay $150 per month.
You multiply the future value?
Yes, if you're given the payments and you're looking for the future amount, it's multiplied. So let's say you're told that you're going to pay $150 per month for 40 years. Let's say you're starting at 25. And you can get a rate of 11%. Find the future value. Let's take a peek. So here's 150 times or divide. Times 1, 2, 3, 1 plus 0.11 divided by 12. Close parentheses to the power of 480 minus 1. Close divided by 0.11 divided by 12. Close and close. 150 times 1, 2, 3. 1 plus 0.11 divided by 12. Close, power 480. Arrow out of the power. Minus 1. Close. Divided by open. 0.11 divided by 12. Close and close. Yeah, I saw that. Thank you. There we go. Did you guys get 1,290,000?
Yeah.
Wow. $19.08. There it is. What do you think? That's doable. 150 a month. You just got to start when you're 25 and get 11% interest. That interest rate when you're young really does make a huge difference. Let's do one more. I think it might be time for a break. Let's try here.
Does the interest rate depend on anything, like your credit?
Not really your credit, but it depends on how long you leave it there, how much risk you're willing to take. And right now, like I said, you're probably in the next couple of years, you're probably only going to get 4, 5, 6% interest.
But if you
leave it there, yeah, it might get more different points.
Your interest is set, is it? Or
You know, sometimes you can get in something that has a fixed interest rate,
or
but right now you're going to get like 3.5% interest on it, and it'll be locked in for the whole term. If you get into a variable interest rate, chances are you can get more out of it.
So you don't want to lock it.
Well, you want something. It depends on your risk
Yeah.
and what your goals are.
high risk, high
There's all sorts of different types of investments. You want growth investments. You want income investments. You want guaranteed and stuff like that. You want to split it up, spread it around. Some that's safer, some that's more risk but more reward. So now let's say that you want in 45 years. Let's say you're 20 and you're going to retire at 65. 45 years. You want $500,000 to retire off of. Figure you can earn 12% on average. Find out how much to put away per month. Let's give it a shot. So this is one where we have the future value. We're looking for a monthly payment, so we're going to divide. So 500,000 divided by 1, 2, 3, 1 plus 0.12 divided by 12. Close to the power of 540 minus 1. Close. Divide. Open. 0.12 divided by 12. Close and close. So 500,000 divided by 1, 2, 3. 1 plus 0.12 divided by 12. Close. Power. 540 minus 1. Oops, minus. Minus 1. Close. Divided by open. 0.12 divided by 12. Close and close. $23.30. That's all you need to put away. What do you think? You didn't need it pressed? If you started at 20, you just had to put away $23, $25 a month and you'd be set?
Just double that.
Oh, yeah. Let's take our break there.